Yes, sir.
अच्छा अब states वगैरह में iron 3 hydroxide, remember it's a base plus acid reaction. Iron 3 means Fe is 3 plus, hydroxide is OH1 minus, so it's going to be FeOH3 plus there's going to be H2SO4 plus there's going to be a salt that would be produced. Get rid of the H, put Fe in its place, so it's going to be Fe3 plus and SO4 would be 2 minus, right? Or water would be produced. I mean, this would be Fe2 and SO4 would be 3. So this is what your reaction is going to be. And you can balance this equation. And you can figure out what the एक second कहाँ पे so you can figure out so Fe that's 2, so this is going to be 2, SO4 is 3, so that's 3, and H is on this side, that's 12, so I think 6 water molecules. ठीक है, that's going to be it. ठीक है, ये समझा?
ठीक
हाँ
है.
हाँ ठीक है. अच्छा ठीक है, now I get it. ठीक है, so we were doing excess method and I'm going to do excess method. I'm just going to cover this briefly very quickly. We were doing excess method, and in excess method what happened was that I told you that all of these reactions, there were, how many reactions did we do? We did solubility and we did 3 reactions. Okay? There were 3 reactions that we had done. It was metal plus acid, it was base plus acid, and you had a carbonate plus acid reaction. So I'm just going to quickly cover the 4th reaction as well. That's a very simple reaction that's used in salt preparation, so which is why it's better to cover that before doing this. That method is so that 4th reaction. Remember reaction number 4. So reaction number 4 is ammonia plus acid. And that produces an ammonium salt. That produces an ammonium salt. That's a 4th. So that's a 4th reaction number 4. Ammonia, remember, is NH3, and the reaction is very simple. It's if you reacted with HCl, what happens is that the H gets knocked out and replaced by ammonium. It's an ammonium salt. Ammonium NH4 plus 1. Ammonium is NH4 plus 1. So instead of the H, you will have NH4 plus 1. That's it. Ammonia with any other acid, the same reaction. If you react ammonia with H2SO4, same thing happens. The H is going to be knocked out and replaced with ammonium. So it's going to be NH4 plus 1. And there's going to be SO4, which would be minus 2. So the formula would be NH4 twice SO4. Or NH3 plus H3PO4. Same thing. Get rid of the H, put ammonium in its place. So it would be NH4 plus 1. PO4 would be minus 3. This is plus 1. So it's going to be NH4 3PO4. TK, is this clear? So it's a simple reaction. React ammonia with any acids.
Yes, sir.
So now we're going to move towards the methods of preparation of salts. So salt preparation. Now remember, we have extensively done 4 reactions that prepare a salt. The 4 reactions that we have covered, just quickly writing that again, it's metal plus acid. All of these reactions can produce a salt. So if you're looking for a salt, you can prepare a salt using any of these methods. Salt plus H2. You can have a base plus acid reaction, and that would produce that is going to produce salt plus water. You can have a carbonate plus acid reaction, and that would produce salt plus water plus carbon dioxide. And the last reaction which would produce a salt is ammonia plus an acid, and it's going to give you an ammonium salt that is going to be produced. So 4 reactions for salt preparation. It's up to you which reaction you want. Every single one of them is going to produce a salt. Now the first thing is, like, if they want you to prepare a salt like NaCl or any salt, let's say they want you to prepare MgSO4, so you should know how to write the equation in reverse. Like if the question specifically is asking you to make MgSO4, so which reaction would you use? Now you can use any of these reactions. Every reaction involves an acid. So if you look at MgSO4, which acid would make this salt? Can you figure out by looking at the formula of the salt?
Sulfuric acid.
Okay, that's going to be H2SO4. Okay, I mean that's the only way the salt would contain SO4. So it's going to be an acid. Now it's up to you. Out of the 4 reactions, you could choose any one of them. You could choose metal plus acid, so the metal would be Mg. But in that case, H2 gas would be produced. Or you could produce the same salt. The acid would be again H2SO4. You could use a base. Base is an oxide or a hydroxide. So it's going to be magnesium oxide or magnesium hydroxide. But in that case, there's going to be a water molecule that would be produced. Or the same salt could be produced using a carbonate plus acid. So the acid would be H2SO4. The carbonate would be MgCO3. And water and carbon dioxide are going to be produced. You can't use the 4th reaction because the 4th reaction is specifically for an ammonium salt. I mean, ammonium salt is this one. It's the one that contains an ammonium ion. So the 4th reaction is very specific to an ammonium salt. So you can't use that. So it's up to you which reaction you're going to prefer. Okay, you've got 3-4 options. So it's up to you which reaction you're going to use. But remember, the acid, guess the acid by looking at the formula of the salt. If I want to make another salt, let's say I want to make aluminium nitrate. So aluminium is 3 plus, NO3 is -1, so it's going to be AlNO3 thrice. Can you quickly tell me what acid would you use?
HNO3.
Okay, so that's HNO3, so it could be a metal plus acid. So it would produce H2 gas, or it could be a base. Hamza, मैं भेजता हूँ एक second. अच्छा, so HNO3, and you could have a base like aluminium oxide or hydroxide. अच्छा, in that case, thank you. अच्छा, in that case, you'll have, how do I, so leave this. अच्छा, in that case, you'll have, ठीक है. अच्छा, in that case, you'll have a water molecule that would be produced. And you can have nitric acid with a carbonate, and that would produce the same salt plus water molecule, plus there's going to be a carbon dioxide molecule that would also be produced. So by just looking at the salt, you can kind of figure out what the reaction is. So the first thing is to come up with the equation of the reaction. Like which reaction would you use to make that salt? That's up to you. Out of the 3-4 options, you can decide. Now the method of preparation, is separate. when we talk about the method of preparing something, that is how are you going to conduct that reaction in the lab. Like if I want to do this, make this salt in the lab, what things should I be careful of? How am I going to make this salt in the lab? So the first method that we did was our excess method. Okay, that was method number one. Excess method was that when you talk about excess method, it should be an insoluble reactant which should be reacting with an acid to produce a soluble salt. Okay, so the salt should be a soluble salt. The reactant might be insoluble. So whenever you see an equation and this is happening, like we did write a lot of reaction. Like if I pick the first one, it's this one is Mg plus H2SO4, MgSO4 plus H2. So if I want to make MgSO4, right? According to the solubility table, MgSO4 is soluble. Like let me open up the acid, bases, and salts datasheet. So anything that contains SO4 minus 2, this part over here, anything that contains sulfate salts are all soluble, except for these 2, 3 salts, all of them are soluble. So that means MgSO4 is aqueous, it's soluble. The acid that would be used is going to be H2SO4, and we can think of the metal Mg. Now Mg is a metal, that's a solid. Acids are all soluble, that's aqueous, and H2 gas would be produced. So you've got a soluble salt that's being produced from a reactant that is insoluble. Okay, so Mg is a metal. Mg is like any metal. That this is what magnesium looks like. Okay, so this is let me just take a picture. This is what a piece of magnesium looks like. It's like metallic. So I'm going to take these. Let's take these pieces. What I'm going to do is I'm going to take these pieces. So that's my metal. And what we're going to do is, here's my magnesium. Okay, so that's metallic magnesium. I'm going to take a beaker, and what I'm going to do with the beaker is, okay, so I'm going to put this piece of magnesium inside that beaker, right? So magnesium is one of my reactants. The two things are going to be reacted. So that's number one. Magnesium is one of my reactant. I'm going to start pouring in H2SO4. So let's say there's a beaker that contains H2SO4. I'm going to start adding H2SO4. So I've got a lump or pieces of magnesium and I've poured in H2SO4, which is sulfuric acid. So that's aqueous. So is this clear so far?
Yes, sir.
Yes, sir.
So immediately what would you see? Right when you add Mg into H2SO4, the first thing that you will notice is that you'll immediately start seeing bubbles of H2 gas being produced. I mean, you'll start seeing bubbles forming because every time the Mg would react with the H2SO4 molecule, it would form a salt and H2 gas. So the salt is soluble. So MgSO4 would be present in the solution, right? Lots of MgSO4 molecules would be produced, like compounds would be produced. A lot of MgSO4 is going to be produced, and H2 gas bubbles would be formed as well. So there would be constant effervescence. Okay, so I can show you magnesium plus acid. It's a very common reaction. Hopefully there is Okay, so here's this reaction going on. Okay, this is kind of, so here's this reaction going on. There's this metallic piece of magnesium. I mean, this is what the true representation is. Okay, so you can kind of see, what you can kind of see is you'll see these tiny bubbles being formed because H2 gas is being produced when you add magnesium to sulfuric acid. Is this clear so far?
Yes, sir.
Yes,
Yes,
sir.
sir.
I said, now the thing is, okay, we are interested in this salt only. I want pure salt. Okay, the whole purpose of the reaction was I wanted pure salt to be produced. So my solution has H2SO4. Now at the moment, the solution has both things. It's got H2SO4 because that's the thing that you added, and now MgSO4 is getting formed, right? Now my MgSO4 salt at the moment is contaminated with H2SO4. What I have to ensure is that sara ka sara H2SO4 na, all of it gets used up. Like the solution, at the end of the day, there is absolutely no H2SO4 molecule left in the solution. Now there's only one way you could ensure that, and that is you keep adding Mg. Add excess of it. I mean, add a lot of it. You keep adding Mg until you're sure that every last molecule of H2SO4 has reacted. Like Mg is reacting with H2SO4. So you keep adding these pieces of magnesium into the beaker. And you have to ensure that every last molecule of H2SO4 gets used up. So your solution would no longer have H2SO4. Is this point clear?
Yes, sir. Sir, एक क्वेश्चन.
Yes.
Yes, sir.
सर हम रिएक्शन को तेज करने के लिए बंसन बर्नर के नीचे रख दें?
हाँ, अगर तेज करना है, if you want to speed up, you can do a lot of things. You can, वो तो rate of reaction में पढ़ेंगे, लेकिन ठीक है,
ठीक है सर.
you can speed it up by increasing the temperature, right? अच्छा,
Yes,
now,
sir.
अच्छा, अभी तो पहला purpose, I wanted to ensure कि the beaker contains absolutely no H2SO4, ठीक है? अच्छा, तो इसकी पहली statement जो होगी, that would be कि mix Mg with H2SO4 aqueous. That's the description of the excess method. As a second point would be, you keep adding Mg in excess until all the H2SO4 gets completely used up. You don't want any H2SO4 in the flask. Okay, all you were interested in was forming the salt. You don't want the sulfuric acid to be present with the salt. You want it to go away. So the only way is you keep adding Mg. How would you know, or what observation would indicate that the H2SO4 is now completely finished? It's completely gone.
सर बबल्स नहीं आएंगे?
ठीक है, क्योंकि every time you add Mg to H2SO4, bubbles of H2 gas are produced, right? So there would come a point when the bubbles would stop. That would mean you still have Mg, like in this beaker over here, you still have Mg, but there are no bubbles forming. That means there is no longer any H2SO4. So Mg has nothing to react with. So keep adding excess Mg until, two observations, until either Mg remains undissolved, like Mg stops reacting, or effervescence stops. Effervescence is this bubbles that are produced. Okay, is this point clear?
Yes, sir.
Yes, sir.
Achha, so what do you do with this extra Mg that you've added? You simply take it out. Okay, if they're smaller pieces, you can filter it out. I mean, Mg is insoluble, so what you can do is you can just pick these pieces, the unreacted Mg, क्योंकि आपने बहुत ज़्यादा Mg डाला था. So what you can do is you can just pick them up and just take them out. Okay, that is something that you can do. So the next part would be, okay, filter out or remove the excess Mg. So you just remove the excess Mg. Bubbles stop हो गए तो इसका मतलब the acid is gone. So this magnesium, ये जो wire है ना, ये ribbon है, that's, you can just simply take it out. That's it. I said now the Mg is also gone. Okay, so the Mg pieces are gone. The bubbles already stopped a long time ago, so they're gone anyways. Okay, because there's no reaction happening. All the Mg is gone. So your solution now only contains MgSO4 because all the acid ended up reacting. वो जो extra Mg डाला था, that ensured that all the acid reacted. The extra Mg was taken out by just filtration, simple filtration. Now the only thing that's left is you filter out excess Mg. The last step is crystallization. If you want pure crystals of MgSO4, you need to get rid of the water. You need to evaporate. So crystallization, the process of crystallization is you evaporate the solution to saturation point. And filter out. You evaporate solution to saturation point and filter out. बल्कि उससे पहले you have to cool gradually. ठीक है, before this, evaporates to saturation point. Cool things gradually. And when crystals are formed, you filter them out. And you dry those crystals in sunlight, or in an oven, or between filter papers. That is the very last thing that you're going to do. So is this all clear?
Yes, sir.
So excess method is whenever you're trying to form a soluble salt from an insoluble reactant. Every time what you're going to do is that the insoluble reactant is always in excess. Okay, this is the one that should be added in excess. You want to ensure that the acid completely reacts. Because your salt is soluble, it would be part of the solution. So your solution should not contain any acid. Like शुरू में तो acid था, but after the reaction, there should be absolutely no acid left in the container. सही है? Is this all clear?
Yes, sir.
Yes, sir.
Just a second. That's an excess method. Okay? So you can apply it to any reaction. Any reaction where the salt is soluble, for example, nitrates. Okay? Remember this. Your nitrates are all anything that contains NO3 that's soluble. Okay? That's one thing. I mean, the 4 compounds that are always soluble. Anything that has group 1, I mean NH4 plus 1, and not oxides and hydroxides, this one. Nitrates, group 1, that's always soluble. NH4 plus compounds are all soluble, and all acids are soluble. So these compounds are all soluble. So anything that contains NO3, that is soluble. So again, you have a soluble salt, and the reactant is insoluble. That's aluminium, that's a metal. Okay, you have an insoluble reactant. So the method would be exactly the same. What will happen is that you'll keep adding aluminium so that all the nitric acid in the solution, it gets used up, and the solution only contains the salt that is produced. That's it. So you have to ensure that every last molecule of nitric acid reacts. तो उसकी वजह से you will keep adding aluminium. You'll continuously add aluminium until the bubbles would stop or the aluminium would stop dissolving or stop reacting, right? In all of them, excess method would be used because every time it's a soluble salt, and this one is also insoluble. This one is also insoluble. So every time it's a soluble salt from an insoluble reactant. So pick any equation as long as, I mean, for example, over here, you can't use excess method for this one. Like you're trying to make iron phosphate, which is insoluble, it's a solid. So you can't use excess method over here. You can't use excess method for, you can't use excess method for making this salt. It's a soluble salt, but the reactant has to be insoluble. Okay, which in this case, it's not. So remember when to use excess method. यहाँ पे हमने ना we wrote states again for Na2SO4. Can't use excess method. Why? Because the salt is soluble, but the reactant should be insoluble. It's not insoluble in this case. अच्छा, for this you can use excess method. ठीक है, इस वाले के लिए you can use excess method. There's a soluble salt, and the reactant is insoluble. अच्छा, what else did we do? Anyone? Again, this one you can't use excess method. So for this, you can use excess method. It's soluble salt, insoluble reactant. For this one as well, it's you can use excess method. It's a soluble salt from an insoluble reactant. And this one as well, soluble salt. It's an insoluble salt, so you can't use excess method. Okay. So make sure the method that I've described for making the salt and this description, you're going to get big questions on this. You're going to get 4-5 mark questions on this. Where did it go? So this one. You'll get big questions on this. So remember when to use excess method. It's always a soluble salt produced from an insoluble reactant. The equation doesn't matter. The explanation would be exactly the same every time. You mix the two reactants. Or the insoluble reactant, that should be added in excess. Achha, is this clear to everyone?
Yes, sir.
Achha, write exactly the same description now. Okay, that's your question now. Exactly the same description. And the question is, you try and make a salt, and the name of the salt is iron sulfate, FeSO4. You're supposed to try and make FeSO4. Think of an equation. That's the first part. I mean, you can use a metal plus acid, base plus acid. So think of an equation. And once you think of an equation, you write the states for that equation. And based on the states, figure out, can you use the excess method or not? Okay, for everyone, remember, what acid would you use to make this salt?
Sir, H2SO4.
Okay, so it's going to be H2SO4, and you can use a metal or a base or a carbonate with H2SO4. So first thing, and if it's excess method, then write the whole description the way it's written above. See it? So I'm waiting for the answer to this. You have to make crystals of FeSO4. The description for an excess method is written above. Salim, this one exactly?
Yes.
So we can try again. Let's try doing this one. Copper. Try doing this one if you're copper nitrate. TSU is 2 plus. Try and write the description for this one.
Okay.
Actually, I'm disconnecting here. Send me the answer to this. Copy both of them actually. ठीक है? FeSO4 and copper nitrate. You have to write the whole excess method. ठीक है? I'll share the board link again. ठीक है? On. Hamza, I'm sending you. चलिए ठीक है. I'm disconnecting here. Waiting for the answer on WhatsApp.
All right, sir.
ठीक है सर.
Okay. Allah Hafiz.
अल्लाह हाफिज़.
Allah Hafiz.